Mm. Hello, and here we go again. We're dealing now with the foundational equation of Einstein special relativity, part 1, introduction. Um, General things here: by light speed, mean vacuum, and in context to inertial frames without influence on it by such fields as gravity. And I use the notation SR to mean special relativity. So what I've done is I've noticed this foundational equation for special relativity that relativity texts seem to miss out mentioning. So I decided to ask AI artificial intelligence about it. So going by my favourite artificial intelligence, ChatGPT, that collects information together which would otherwise be difficult to obtain. So I get the equation from the light clock. They have this light bouncing up and down between two mirrors, and it forms a triangle, which is the Pythagorean triangle. And you have a horizontal distance for that triangle of being VT, and you've got the other distances for that, the sides. So, question I'm offering to AI is from a light clock we have a right angle triangle with horizontal that's horizontal distance is equal to VT, and you got a vertical of C prime T prime and a hypotenuse CT. We can then form by Pythagoras this equation, and in that equation if C prime is equal to C, then we can form the time dilation equation question mark. And AI ChatGPT says yes. And let's go carefully step by step, because the way you wrote it makes you some notation and subtle mistakes can creep in, and AI doesn't mention any mistakes when it deals with it. So first of all, AI is going to drive the special relativity time dilation equation using C equals C prime in my equation. And AI says we are talking about the classic light clock derivation of time dilation in special relativity. Consider a light clock moving at horizontal speed v relative to some observer. So you then set up a triangle where the clock moves horizontally at speed v in time t. It moves a horizontal distance vt, and the light travels along the hypotenuse of a right angle triangle, vertical distance of ct prime, and horizontal is vt, and the hypotenuse is ct. So then by Pythagoras you can um, bring these distances together in that equation shown. So as noted, that's for my equations using C equals C prime. So I'll enter that. AI continues, solve for t in terms of t prime. And so it goes through all that, and it ends up with the time dilation equation. And it says this is exactly the time dilation formula for special relativity. It's me, so I'm talking now. So AI has derived the special relativity time dilation equation, and next it's going to note that using C equals C prime in my equation, it's saying this. Key points about your notation: C prime is usually not introduced. The light speed is the same in all frames in special relativity, and that is meaning C prime is equal to C. The vertical distance is equal to CT prime. It is the proper length of the light path in the clock frame. The horizontal displacement is Vt, is in the observer's frame. If you assume C prime equals C in the clock frame, then Pythagoras' theorem directly leads to time dilation. So AI is noting that using C equals C prime in my equation and assuming that T does not equal T prime, then get the special relativity time dilation equation. So next I ask AI if use T prime is equal to T with C not equal to C prime in my equation, does that give Newtonian physics? AI ChatGPT says yes. And let's go carefully. You are asking about the opposite situation to special relativity. Suppose the clock time T prime is equal to the observer time T, i.e. no time dilation. Then if we still use the light clock setup, the Pythagorean relation becomes the following equation. And if you divide both sides by t squared, since t now equals t prime, you end up with speeds. You got c squared is equal to v squared plus c prime squared. So in order to keep t is equal to t prime, the vertical speed of light c prime in the moving frame must satisfy that following equation, which is c prime is equal to the square root of all the c squared minus v squared. AI then says that's exactly the Newtonian stroke Galilean idea of velocity addition, where the speed of light relative to a moving object is not invariant. It changes depending on the motion of the observer. In other words, if you insist on absolute time t equals t prime, then the speed of light cannot remain constant in all frames. It must change according to the motion. This reproduces a pre-relativistic Newtonian picture, and I don't like the term of calling it that. I mean, Newtonian physics does have a relativity version of its own, normally called Galilean relativity, but saying it's pre-relativistic means it's not Einstein relativity. So in the Newtonian picture, you've got absolute time and variable light speed. So AI then says yes, t prime equal t with c prime not equal to c gives a Newtonian light physics, or more generally a neo-Lorentzian stroke ether based framework where light speed depends on the frame. So it's agreeing with me that it gives a Newtonian light physics. So I then say that my equation is foundational for a divergence between special relativity and Newtonian physics. Because when you have c prime is equal to c with t prime not equal to t, you get special relativity, and when you've got t is equal to t prime with c not equal to c prime, then you've got Newtonian physics. AI says exactly you've captured the cool divergence between special relativity and Newtonian physics for a Lorentzian stroke ether viewpoint. And it wants to summarize, but I've basically covered with what it's summarizing there. So AI is pointing out that special relativity assumes c prime is equal to c, and that's the light speed being invariant in all frames. And then it puts that into my equation, and it gives the time dilation equation. So in the case of Newtonian stroke Lorentzian ether picture, Newtonian physics assumes t is equal to t prime, and that's absolute time, and then you get the equation for light speed c prime is not being constant, and there's no time dilation, and we dealt with that earlier. So AI then gives the key conceptual divergence. You have in special relativity, time is relative, and Newtonian stroke ether theory, you have time is absolute, and then in special relativity, you've got light speed is constant, but in Newtonian stroke ether theory, you've got it as variable, and both those results are derived from the same foundational equation. AI then says, so yes, that equation, what I call the foundational equation, is exactly the fork where special relativity and Newtonian physics diverge. That's where whether you keep the light speed constant or keep time absolute. So I point out to AI that I haven't seen my equation in relativity text. They present a similar equation, but it doesn't have the dash in it, which is C prime. So AI then says, yes, that's an important clarification. You are correct. In standard relativity text, the derivations usually does not introduce a C prime. Instead, they use the light clock derivation in that form shown. So they're already assuming C equals to C prime. So AI goes on to point out that my foundational equation is not standard. It's not something that the text we usually mention. Introducing C prime as a different speed is essentially a neo-Lorentzian stroke ether-based perspective where time is absolute and light speed varies in moving frames. Standard special relativity texts don't need C prime because time dilation is derived by you keeping C invariant, i.e. they're using C is equal to C prime. So in short, textbook special relativity gives that equation shown, and the Lorentzian equation is that equation shown with T prime is equal to T, which has then variable light speed and no time dilation. So relativity texts don't point out where the equation for this Pythagorean triangle, which they're given to us, diverges from Newtonian physics to special relativity. So my question is, so the foundational equation is missed out for most relativity texts. AI says, yes, that's correct. Most standard texts don't explicitly write the equation in the form that I've written it because they never introduce a separate vertical speed, C prime. Instead, they just go straight to the equation there shown and then solve for T in terms of T prime, assuming C is invariant, which is meaning C equals to C prime. AI carries on why it's usually missed. That's number one, it's special relativity philosophy. Light speed is invariant, so there's no need to define a separate C prime. The vertical leg of the light clock is just C T prime. Number two, time is relative. The derivation directly solves for T, dilated time, rather than changing C. Number three, neo-Lorentzian perspective. Introducing C prime is exactly the route you take if you wanted absolute time, where T equals T prime, and variable light speed. Standard special relativity texts avoid this entirely because those relativity texts reject absolute time. So AI says, so yes, the the form which I've written as the foundational equation is essentially a hidden or alternative starting point which appears naturally in ether stroke Lorentz style derivations, but it's also almost never written in modern special relativity text. So they don't highlight how Newtonian physics and special relativity are connected by this equation. And AI replies, exactly, that's the key point. Most relativity texts never highlight that simple equation as the conceptual bridge between Newtonian physics and special relativity. They just, one, start with a light clock, use the Pythagorean theorem, assuming invariancy. They're not telling you, this is me commenting now, they're not telling you what the Pythagorean triangle would be if you weren't assuming invariancy. And then number 3, which is AI, says it solves directly for the time dilation equation. AI doesn't point out the same Pythagorean relation would also be written as my form, and that from that foundational equation, c prime equals c, then t does not equal t prime. It's time dilation, while from the Newtonian Lorentzian point of view, t equals t prime, and then c prime does not equal c. You've got variable light speed. So the conceptual fork between absolute time and invariant light speed is hidden. It's buried in the derivation rather than emphasized as a foundational equation connecting the two theories. In other words, the standard text jumps straight to special relativity, assuming light speed and invariance, and never show how you could instead keep time absolute and let light speed vary. So note the word hidden. Relativity texts are keeping some things hidden. So AI is pointing out the setup which is shared by both derivations, which I've gone into before. And so path A is the one which gives you special relativity, and I've gone into details about that already. AI is just repeating itself, and so you get invariant light speed and the time dilation equation. And path B, you end up with Newtonian Lorentzian absolute time, and I've gone into that also. So the effect that special relativity calls time dilation is just what Newtonian physics would call variable light speed. So you're changing your concept thing here. What Newtonian physics is treating as variable light speed, special relativity, you could change that concept and have time dilation instead. So AI then gives remarks on subtleties. It states that the special relativity texts usually just assume invariance of light speed, and so they just assume c prime equals c, and they don't even mention it. And so, as it mentioned, they hide the alternative assumption. Number 2, which assumption is philosophical versus empirical? Special relativity trades absolute time for invariant light speed and predicts numerous experimentally confirmed effects. Time dilation, relativity of simultaneity, Lorentz transformations. And that's their claim. Next, the Newtonian stroke ether route instead keeps absolute time but must explain variable light speed and account for experiments such as the Michelson-Morley experiment and so forth. Historically, that required additional mechanisms of length contraction, etc., to max observations, and that was the Lorentzian program. And I'll be going into more details about that in further videos. Number 3, be careful about physical interpretation of C and C prime. The relation of C prime is equal to the square root of all things C minus V squared. close brackets, comes from the specific geometric setup above, whereas being above is earlier mentioned about the Pythagorean triangle, where the hypotenuse speed c fixed in the observer frame. If you instead assumed a simple Galilean velocity addition for light, namely c prime is equal to c minus v, you would be making a different geometrical stroke kinematic choice. The precise formula depends on which speeds you hold fixed in which frames. And so my note on that is, if you were using that formula of c prime equal to c minus v, you would be messing things up in the context of the Pythagorean triangle, where the speeds are being treated differently to that equation. So this talk serves as an introduction to the foundational equation of special relativity, stroke Newtonian physics divergence. Other talks will go into more details. So to be continued.